Hi, let's look at a home mortgage calculator. This is the most complete loan model that I was able to put together by looking at several and choosing the best from each of them. We'll start with the purchase price. I've already formatted a lot of these cells. So let's say we want to buy a $100,000 home. We want to put 5% down. That leaves us with the purchase price times 1 minus the down payment. And then we need to decide the length of time we'd like to pay off this house. It's going to be 15 or 30 years most likely, so we'll start with 15. And an origination fee is a fee that the bank charges, usually about 1% of the loan, to put the paperwork together and do all the work on their end. So they get paid for a lot of their costs up front, in addition to the interest that they'll get paid over time. Another thing they can do is let you adjust your interest rate by paying some upfront costs. So let's say we pay 2 points, and what the bank says, well, if you'll pay 2% of this original loan amount, then we'll come over to today's table and say for 2 points, you can get a 15-year loan for 2.6% or a 30-year loan for 3.1%. These are completely made up numbers. You'd have to go to the bank for some exact numbers. Then the total closing costs are going to be the amount of the loan times the percentage fee that the bank charged to originate it, plus the number of points. And those are whole numbers that represent percentages, so I'm going to divide that by 100. So in this case, we're paying about 3% of the loan. So 3% times 95,000 is $2,850. And from that, we can get an annual interest rate. Now we need a way to look up from this table. I could just make that an input. I'm going to make it a lookup here. And the way I'm going to do this, you're familiar with the index function. The index says, if you'll give me a list of numbers and tell me which row you want, then I'll pull it out of that number. Well, we can also tell it which column we want if the original array has more than one column in it. So in this case, I want to pull out the 1, 2, 3, 4, 5th row. And since my loan term is 15, I want to pull out the first column. So what I could do is say comma 5, comma 1, break a couple of modeling rules, but that would get me to that 2.6% interest rate. So let's do better than that. Instead of hard coding the value of the 5th row, let's use match and say match that number of points in this column. I think it's better if we ask for an exact match, just so it throws an error if we don't find an exact match. And so match E8 within G4, looking for an exact match, should give us the 5th column. We can do the same thing to match the loan term in this series and look for an exact match as well. And we still get the 2.6. The next thing we need to think about is how many payments per year. Almost every loan is going to be monthly payments, so I'll hit 12, but we could model quarterly or otherwise. Then we need a periodic interest rate. This is the only time in finance that you will get to do something as simple as take an annual rate and divide it by the number of payments per year. It's completely wrong in terms of any finance theory or compounding interest calculation. It's just a nuance that the bank uses to make the math simple and to actually charge a slightly higher interest rate than you would think you're getting. Compounded 12 times per year of 0.22, it's going to be higher than 2.6. And then the number of payments, of course, is just going to be the loan term times the payments per year. And so we can calculate a scheduled payment. I'll use the PMT function and take this monthly rate, the number of monthly periods, and the present value of the loan. By omitting future value, we're simply saying that we're going to pay off the entire loan in 180 payments. And by leaving type omitted, we're simply saying that these payments occur at the end of the month. So if I say enter on this, watch what happens. I get a negative number. This is an outflow. The bank gave me $95,000 and I give them back $638 over a long period of months. I'm going to put a negative sign. I could put it in front of the PMT or I could put it in front of the PV, and it will make my dashboard area or my input-output area look a little bit better. There's another nuance that happens with home mortgages: annual private mortgage insurance as a percentage of the beginning balance of the loan. So let's say that the bank says we're going to have to pay 1.2% of the beginning balance of the loan, 1.2% of $95,000 as long as you have less than 20% equity in the house. So that equity threshold is generally 20%. So a lot of times you can get a loan for as little as 5% down, or even less if you have special qualifications. But if you'll pay 20% down, then you won't have to pay the private mortgage insurance. So we need to calculate that periodic PMI as the annual amount of the original loan divided by the number of payments per year. So that's going to cost us $95 a month. And then if we have any late payment charges, let's say the bank tells us any late payments will cost us $100, and the close date, we'll go ahead and put in some date. I'll put in today's date. Now, one of the things we want to get out of this model is what's our actual cost of borrowing. So we know what the bank said our annual interest rate was. I already said that the actual cost is going to be a bit higher because it gets compounded monthly. But I'm also paying 1% to get the loan and a couple of points to get a lower interest on the loan, possibly some private mortgage insurance, and possibly some late payments if I make. So each of those things make the annual percentage rate go up above the stated interest rate from the bank. But we'll build a table. We'll come over here and look at our cash flows, and then we'll calculate that annual percentage rate. So the first thing I want to know is what's the due date on the loan. Notice I have put down here, I'll do a control down to show you that I've got 360 payments, and a control up to get back where I came from. Roll this mouse wheel up a bit. And that will allow me to do a loan term of up to 30 years of monthly payments. I guess I could make that longer, but I don't see loans going longer than that. So we'll start with that. Now, what happens in period 0? Well, I don't make any payments, but I am going to get the loan funded. So I'm going to come over here and say that I have a positive cash flow of $95,000 from the bank. I have a negative cash flow of the closing costs. Not paying any PMI or late fees or interest or principal yet, but the total cash flow for me is only $92,150. So even though I thought I borrowed $95, by the time I paid the closing costs, I only got $92,150. I'm not going to worry about these dates for now. I'm going to come over here to the main part of the model with the beginning balance, which is going to be simply the loan amount. And then calculate how much interest would accrue over that first month. So it's the loan amount times the periodic interest rate. That's something I'm going to use again, so I'll do absolute references on it. So it's going to cost me $205, almost $206 to borrow $95,000 for a month. Now my scheduled payment that the bank told me I would have to make is the $637. Let's go back and fix some conventions here. I'll make both of these negatives to indicate that there are outflows. And then if I wanted to make any extra payment, I could. That's something we could get fancy on a dashboard with, but we won't do that yet. So my total payment is going to be the sum of any extra payment plus my scheduled payment. So the principal applied is going to be everything I paid the bank minus the accrued interest. And so the ending balance is whatever the beginning balance was plus that principal that was applied. I'm adding a lot of negatives here, but just bear with me. So my ending balance at the end of that first month is $94,500. So where do I get the beginning balance for month 2? Well, that's just the ending balance for month 1. And the accrued interest is going to work the same. Copy this down and say that to borrow $94,568 for a month at this interest rate is going to cost me slightly less than it did to borrow $95,000 for a month. My scheduled payment is still going to be the same, so let me use some absolute references and copy that down. I'm not going to make any extra payments yet, but I can copy these other formulas down. Looks like they're working correctly. Now that everything on this line is looking at either the current or the prior period, I can copy this down all the way to the bottom. What's the quickest way to get there? Control left, down, right arrow a couple times, Control Shift up, and Control V to paste. And so look what happens. Each month it costs us slightly less interest because we're borrowing slightly less money from the bank for that month. But our scheduled payment is calculated such that whatever doesn't go to interest goes to principal and reduces the balance. So I'll bet if I came down here to period 180, I would see that after the 180th payment, my balance were zero. Now you might notice it's not exactly zero, it's red, which means it's somewhat negative, probably out in the 10th decimal place, because when we calculated that payment and applied it 180 times, it was very, very slightly off, but well within the precision of what we care about. So we've paid the loan off in 180 payments. We don't want to keep making scheduled payments. So let's go back to the top, Control up, and see if we can put some kind of a formula on here to limit that scheduled payment. The first thing I'm going to do is get rid of the scrolling here by saying, well, let's assume we paid an extra $93,000 here in that second period. Doing Alt toy to see those numbers. And that paid off most of our loan. So now I don't have to scroll up and down so for us to see the end of the loan. We're going to make another scheduled payment, which is going to get us down to $499. But if we make that fourth scheduled payment, that's going to get our ending balance negative, too much. So let's put a limit on how much this can be. You might say, well, it shouldn't be any more than the beginning balance, but that's not true because we need a little bit of interest to borrow that $499 for a month. So what it's actually going to be is the larger of this scheduled payment or the outstanding balance. We'll need a negative on that, plus the interest. If you'll check me on those negative signs, I think you'll see that it works correctly and pays our loan off to exactly zero by paying the amount of the beginning balance and the interest. If I'll copy that up and down this entire column, then I find out that no matter how much I pay off, if that were only $83,000, no matter how much I pay off, I'm going to get to some final payment where I make the scheduled payment only enough to cover the remaining principal and the interest. We've now completed this principal and interest portion of the loan. What I'd like to do now is look at what are our actual cash flows so that we can calculate the annual percentage rate of the loan. So as we said, at closing, the bank brings $95,000 to the seller, but we pay the bank $28.50 to get the loan. And so our net cash flow at closing was a positive $92,150. Our cash flows after that are going to be any interest and any principal. Let's skip late fees for now, but talk about the private mortgage insurance and say if the amount of my loan divided by the value of the house, and the best thing I know in this model about the value of the house was the original purchase price. So if that loan to value is still larger than or equal to 1 minus this equity threshold, then I need to go ahead and pay the private mortgage insurance. Otherwise, I don't. First, let's copy the total down, cash flows, and then let's copy these. I'm going to paste them in column O all the way down through the 360th payment. So Control left, Control down, column O, Control Shift up, paste. If I go back up, looks like I left out an absolute reference. Let's see where I did. Both on E16 and on E17. Where else? The rest look good. So now I can just double click on that one. And so I'm paying the private mortgage insurance, the interest and the principal, through about $80,000. So once I get the loan down to about 80% of the value of the house, I can stop paying the mortgage insurance. So when we talk about an annual percentage rate, it's including the mortgage insurance and any late fees that we add here in a moment. So let's get to that number. How do we get to that? Well, first we have to calculate the periodic interest rate of these cash flows. That's easy. That's the internal rate of return function. Internal rate of return function doesn't care what the periods are. It just tells you what the periodic discount rate would need to be to make the NPV zero. So if I take that, now I can actually use the real finance compounding formula and say 1 plus that interest rate compounded by the payments per year minus 1 gives me the annual percentage rate. So even though I thought I was getting a loan for 2.6 annual interest rate, by the time I added on the origination fees, the points, and the private mortgage insurance, and then I compounded this monthly interest rate 12 times, all those things bumped that annual percentage rate up to about 3.6%. Now, let's talk about the late fees. Notice that I skipped over the due date and the actual date because we were simply talking about 181 different periods, the time zero at close, and then about a month after when we started making payments. Let's talk about how it really works in the real world, because every month doesn't have the same length, and we probably don't close on the first of the month necessarily, or all the title companies would be really bored for the other 29 days of the month. So I'm going to put in another date up here, another input, and call it close date, and first payment due. Almost fit those on one column. And let's say that I close, what's today, March the 12th. I went out and looked on the internet and did some Googling, and my conclusion is that most people say your first payment is due the first day after the first full month after you close. So the first full month after I closed would be April, and the first day after that would be May the 1st. So I need a formula that will convert this date to May the 1st. And the type of formula I am going to use is date. So what I really need to say is date 2021, month 5, year 1, and that will give me May the 1st. Now, obviously, we're breaking modeling rules there, so we can't do it that way. What we could do, though, is say take the year of this date and take the month of that date plus 2, month of that date plus 2 more months, and then go to the first day of the month. I may pause the video and check and see if that's a problem if I close on the first of the month, but in general, that should give me May the 1st. And again, if I get on that and do a shift F3, it's telling me that the date function requires a year and a month and a day. And to find the year, I can use the year function on this date, the month function on this date, and I'm always going to want this to end up on the first day of the month, so I'll just use a 1 in that. Now, let's see what happens if I happen to close on December the 15th. Is that going to give me the month being 12 plus 2 for 14? Let's see how that works. So the year of this date is 2021. The month of this date is 12, and then when I add 2, I get to 14. And then the day that I want to use down here, I'm hard coding as 1. So notice it gives me the date that I'm looking for. And by the way, Excel thinks about dates in days since, I think it's the year 1901 or something like that. So it thinks of them as numbers, but formats them as dates. Okay, I paused the video and tested this for the beginning of the month, the end of the month, and I was pretty happy with how our formula works. So we'll roll with that. I'm going to move that back to today's date. And in our little example here, that would be our input. So if we close on this date, when our first payment due is pretty important. That may be important enough to format as an output. Some of these other intermediate outputs I didn't format as outputs, only the ones that I thought were important. Now let's come populate these two date columns. The due date, let's just plug in the close date. It doesn't get used for anything in column C. And let's plug in the first payment due after that. And from there on, I need to find the first of each month. So I'm going to use that same date function and say, give me a date for the year of the previous payment and the month of the previous payment plus 1 and the first of the month. So when I copy that down, if I go all the way to the bottom, it should have counted up 360 months and given me the first of each month that those are due. Now the actual date I don't know about you, but I don't pay all of my bills on exactly the day they're due. Now, the close date we can be pretty firm on, so we'll just say that the actual date of close was when we plan to close. But I'm going to randomize this a little bit. This will be mainly for the purposes of the video, but it'll be a good review of how to randomize a variable. Let's say that about 1 out of 10 times I'm going to be late on a payment. So if some random number between 0 and 1 is less than 0.1, which would happen 1 out of 10 times, then I'll be 1 day late. So I'll be the date it was due plus a day. Otherwise, the other 90% of the time, I'll be anywhere from 0 to 5 days early. So the date it was due minus some random number between 0 and 5. So let's say rand between 0 and 5. Let's see how I do. So 3 days early, couple days early, couple days early, early, on time, early. Okay, took about 8 times, and I finally found a month here where I was 1 day late on the payment. Let's see how that would affect our late fees. Equals if this is greater than the due date, then go ahead and put in a negative late fee, otherwise 0. Now, of course, with my randoms over here, you know from before, oh my, that'd be a big late fee. Maybe we should put an absolute reference on this one. You know from randomizing variables that every time Excel recalculates, it's going to change these. That's not helpful in my video or for any other purpose. So I'm going to copy and paste them as values. And now they won't change. But I do have a kind of random sample in here for those actual dates. Now, the randomizing of that variable is not really part of building a loan model, unless I guess you wanted to model that. But I included it here for a couple reasons. One was a quick way to get a few late fees in there. And 2 was to remind you how to randomize variables. So where I do have the late fees, when the payment was late, then I'm incurring the extra $100. And if I scroll down through there, it looks like it's about 10% of the time. I really hope you're more punctual than that on your payments. Electronic withdrawal is a wonderful thing. But what we've got here now is an extra payment going into our total cash flow. So look what it did to our APR. The fact that I've got some late fees in here bumped that annual percentage rate up. But did anything else bump that annual percentage rate up? Look at this. Every one of these, well, not every one, but most of these payments I'm giving to the bank before it was actually due. And so I'm losing a little bit of time value of money there. So let's see how different this would have been had I not had any late fee at all. So if I change that to 0, then the late fee portion took me from 3.58 up to 4.02. So it was the bulk of that fee. These very small early dates had very little to do with the actual annual percentage rate of the loan. Now, there is one more thing I would like to show you since we have some actual dates for these cash flows over here, and that's the IRR function. So let's look at dated cash flows. And let's see if these weren't really, we just assumed they were all a month apart. But let's look at when they actually occurred. In fact, I think I'll move that right here so we can see it easily. Equals. Use, instead of the IRR function, the XIRR function for these cash flows. Control Shift down, comma, and these dates. Control Shift up, Shift down. And so the XIRR function needs both the values and the dates that correspond to it, and it will give us an answer in annual terms. So we say OK. Convert that to a percent, show a couple decimal places. And we see it's slightly different than this. It's a slightly lower rate of return. Do you think that's because these didn't happen at exactly the first of the month or some other reason? So let me go back and use some absolute references. And copy that over here. So even if I use the due dates, it was still slightly different. So this is just the difference in how the days fall within the month. We get basically the same answer, whether we pay a few days early or sometimes late, or whether we pay as scheduled. But the big difference between either of these and the very slightly higher number of 4.02 probably comes in this gap here. We have a month and a half gap there instead of just 1 month. And that's a long time to wait if you're looking at it from the bank's perspective and you've invested $92,000. It's a long time to wait for your first payment. For our borrowing cost, it's a nice long time to wait, which good time when you just bought a house, right? To get to wait about 6 weeks for that first payment. So it actually lowers your APR a little bit when we look at the actual timing. Nonetheless, they were affecting it. We now have about the most complex loan model that I can come up with. I've tried to throw almost any realistic thing in there for you. I hope this has been interesting, helpful, and maybe even something you can take away from this class.